Hi, welcome back. In this video, we're going to talk about composition of functions. Now, in this particular video, we're going to focus on purely the equations and what does it mean to have a function composed of another. Now, we've spoken about function operations like f plus g of x, f minus g of x, f times g, and f divided by g. In these scenarios, we are adding, subtracting, multiplying, and dividing functions to create a new function. A composition is very similar, where we're creating a new function, but without using an operation. Here's what I mean. This notation, unlike our multiplication, it's a circle. The circle means of. Okay? Now what this notation means or signifies is that we have a function of f that is composed of a function of g. So we use function notation like f of x, where f is a function where x is the input, right? This is defined as my input or my x values that I'm interested in. So when I have f of g of x, or f is composed of g of x, what this means, it means that f is my main function and it's going to be composed as g of x as the input. Now g of x, this function, becomes the input for the f of x function. How does it change over here? Well, now we have g is composed of f of x. What does that mean? It means we have g as the main function, and we're going to plug in, we'll do a different color. We'll do f of x as my input. G is composed of f of x. Very similar to when we blow air in a balloon, right? If you blow air in a balloon, that balloon is composed of oxygen. You put helium in the balloon, now that balloon is composed of helium. It's what's inside it, right? Our bodies are composed of organs and bones and all kinds of stuff, right? So we are composed of those different things. Think of the same as a function, right? This function will now be composed of a new one. And as a result, we will have a brand new function. So let's do an example or two of what this looks like and what it means. Here I have two functions. I have f of x and I have g of x. This tells me that g of x will be the input for f, right? F is composed of g of x. So f is my main function, and g of x becomes the input. The first letter is the main function we're going to plug things into. So we're going to take f of x, and I'm going to write that down. F of x equals 2x minus 3. The input in here and in here, right? Anywhere we see an x value, we're going to replace that with the g of x function. So g of x is my input into f. So anywhere that I see an x, I'm going to replace that with this function, which is x squared. Now, we can't really combine anything here or simplify anything. So we're going to write this as f of g of x is equal to 2x squared minus 3. There's no like terms. There's nothing to simplify or combine, right? So notice how this function changed. It became a combination of these two, where this function is now composed as this one inside it. Our phones work the same way, right? We could have a phone composed of multiple apps. And inside those apps, you can do different things. You can play games, you can take pictures, you can post stories, you can do all kinds of stuff, right? But our phone is composed of different apps. Well, here we have a function, g, composed of f of x. Now, f of x is my input. And I'm going to plug it in to the g function. So what does that look like? Well, I take my main function, g of x, and I'm going to replace x, the input, with the f function. So I'm going to plug that in here. I have g of f of x. And anywhere that I see an x, I'm going to replace it with the function f of x, which is 2x minus 3. The entire function becomes my input. And now here I can expand that, I can do FOIL, I can multiply and do the rest of the things, right? So now I have g of f of x equals 2x minus 3 squared, which means 2x minus 3 times 2x minus 3. Right? The exponent tells us how many times I'm going to multiply itself by. And now I can simplify this. I can multiply using FOIL. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2 is negative 6x. And negative 3 times negative 3 is positive 9. By combining like terms, which are these values, I get g of f of x is equal to 4x squared minus 12x plus 9. Notice how this equation, my new equation, was created by using these two functions. It was created by plugging in f of x, all of that, into this equation. And that's the essence of this, right? We're creating a new equation, but not by adding, not by multiplying, not by subtracting, not by dividing. We're doing it by taking an equation and putting it in as the input of the other. It's composed of something, right? The function is composed of a bunch of inputs. Well, this input happens to be an entire function, which then creates a new function. All right, let's talk about evaluating. Before we evaluate, feel free to pause this, give this one a try. Feel free to check it out, right? If you feel confident with the previous two examples, you can go ahead and fast forward a little bit, and you can go into evaluating, which is slightly different, okay? This is purely for examples in case you need more examples. So what does this look like? Here I have the main function where g of x is the input. And here the main function is h, where g of x is now the input. I first always want to be able to work with the notation. And then I have three different functions that I can work from and work with. So I'm going to take f of g of x. I'm going to start with f. And for g of x, I'm going to plug in the entire function is going to go into f. Right? That's my notation. So I take my original, the main function f, which is the square root of x, and I'm going to replace the input. This is my input. I'm going to put in all of g of x, which is 3x plus 1. Now here I can't combine like terms, I can't simplify, so that becomes my function. F of g of x is equal to the square root of 3x plus 1. I can also use this other notation if I prefer, f of g of x, to say the same thing. How would I do it over here? I strongly recommend when you're watching these videos to press pause, to try it yourself, and then unpause it and see if you're getting the same thing that I'm getting. It's just good practice. So I take the main function, which is h of x, and I'm going to plug in g into it. So the main function is 2x squared. That's h, right? I'm going to replace the input with g. So anywhere I see an x, I'm going to plug in the entire equation of g, which is 3x plus 1. Now this I can actually simplify a little bit. When you simplify, make sure that you use PEMDAS, our order of operations, to help you go through the correct process. Which means I have to do the parentheses first. Inside the parentheses, is there anything I can combine? No. Are there any exponents? Yeah. So let's do that part first. 2 times, what does that mean to be squared? 3x plus 1 times itself. Twice. People tend to want to multiply the 2 in first, but multiplication comes later. Let's do the exponent part first. So I gotta multiply these. 2 times, this is 9x squared. 3x times 1 is positive 3x. 1 times 3 is 3x, and 1 times 1 is 1. Now I can distribute the 2 into the whole thing. Now multiplication can occur. And here we get, well actually before I multiply, I can actually combine like terms a little bit. Let's do this. 9x squared plus 6x plus 2. Let's now distribute. Even if you distributed it here, you would have just doubled everything, and then when you combine like terms, you would have gotten the same solution. So 2 times 9 gives us 18x squared plus 12x, right? 2 times 6, and then 2 times 2 is 4. So this is h, where g of x is my input. X of g of x. Okay, let's evaluate. Let's talk about what that means. As we look at this notation, what is changing? This is still f is composed of g, right? We have f of g of x as my input. This is my input. But what am I replacing x with? I'm replacing x at a specific location. So this can be expressed as f of g with 1 being the input. What does that mean? It means that now I want to know when x is equal to 1, what does g of x become? Right? 1 is now the input of g. So this is what it looks like. I'm going to replace all of this with our g of x function. So I'm going to put 1 squared minus 1 minus 2. Notice how g of x, we want to evaluate what happens when x is equal to 1. And I plug it in here and here. And I now want to do some PEMDAS. 1 squared is 1 minus 1 minus 2. If I simplify, I get 1 minus 1 is 0 minus 2. Now I have negative 2. The entire g function equals negative 2 when I plug in 1. Now, I want to take the output of g and plug it in to f. Yeah. So now I take my f function and plug in negative 2. So f of x equals x minus 2 divided by x plus 1. And I replace every x value with a negative 2. Negative 2 minus 2 divided by negative 2 plus 1. If I do some PEMDAS on the top, negative 2 minus 2 is negative 4, divided by negative 2 plus 1 is negative 1. Negative divided by a negative is going to give me a positive. So what's different here? When we're evaluating a composition of functions, we want to know what is the value of this function when this one, the input is 1. We'll plug in 1 into g, we get an answer, which was here, and then we plug the answer of g into f. Let's try another one just for some practice. Here we're going to have g composed of f, and f is composed of 0. So first, we need to plug in to f. Plug 0 into f of x. Right? Once I plug 0 into f, I take my answer and I'm going to plug that into G. So let's do this. G of f of 0. I plug 0 in here, which gives me 0 minus 2 divided by 0 plus 1. That's this piece, right? I plug 0 in f of x. I end up getting G equals negative 2 divided by 1 gives me negative 2. Now that I've got the answer, or the value of f of x at 0, I can take my answer and plug it into G. Hence this right here. I'm going to plug negative 2 into G equation. And G is x squared minus x minus 2. This is G of x. I'm going to plug negative 2 in for G. And that gives me negative 2 squared minus negative 2 minus 2. Negative 2 squared is a positive 4. Negative times a negative is a positive. And as I combine like terms, I get 6 minus 2, I get 4. So, G composed of f at 0 gives me 4. Okay? Please let me know if you have any questions. Don't forget to like and subscribe if you haven't already. And as always, we'll calculate.